This is Christopher Sernaque, hosting episode 5 of season 5 of the Current Topics in Science podcast. This podcast will address breaking scientific news in light of the origins debate and host interviews with scientists. Today we'll be speaking with Dr. Casey Luskin about whether or not the materialistic worldview best explains reality and cover his positive case for intelligent design article series. This podcast is available on the following platforms: iTunes, Stitcher, Google Podcasts, Spotify, and iHeartRadio. Video recordings of the podcast will be uploaded to YouTube. Enjoy the podcast. Today on Current Topics in Science, we have the honor of hosting Dr. Casey Luskin. Dr. Luskin has a Bachelor and Master of Science degree in Earth Sciences from the University of California, San Diego, where he studied evolution extensively at the graduate and undergraduate levels, and conducted geological research at Scripps Institute for Oceanography. Dr. Luskin also has a PhD in geology from the University of Johannesburg, where he specialized in paleomagnetism and the early plate tectonic history of South Africa. Dr. Luskin is also a Juris Doctor, having obtained his law degree from the University of San Diego, and has served as a California licensed attorney since 2005, practicing primarily in the area of evolution, educated in public schools, and defending academic freedom for scientists who face discrimination because of their support for intelligent design. Dr. Luskin has published in science journals and technical law journals, such as the Journal of Nature, Science, Geochemistry, Geophysics, and Geosystems, South African Journal of Geology, Montana Law Review, the Journal of Church and State, the University of St. Thomas Journal of Law and Public Policy, and Dr. Luskin is a regular contributor to Evolution News and the ID the Future podcast. Dr. Luskin is also the co-author of numerous books, such as Traipsing into Evolution, Intelligent Design, and the Kitzmiller vs. Dover Decision, Discovering Intelligent Design, Science and Human Origins, The Comprehensive Guide to Science and Faith, a book that won an honorable mention in the World Magazine's 2021 Accessible Science Book of the Year Awards, and Dr. Luskin is the co-founder of the Intelligent Design and Evolution Awareness, or IDEA Center. He's also the assistant director of the Center for Science and Culture at the Discovery Institute. He's married to his beloved, and he continues to pursue his interest in geology, science education, biological origins, and environmental protection. Now, without further ado, good afternoon, Dr. Luskin. How was your day, and how are you doing?
It's great to be on your show. Thanks so much for having me.
It's a pleasure to have you on Current Topics in Science, Dr. Luskin. And now, since this is Current Topics in Science, we're going to quickly look at this week's current topic. An article called How the Physics of Nothing Underlies Everything, published on Quantum Magazine, has the tagline, "The key to understanding the origin and fate of the universe may be a more complete understanding of the vacuum." Later on in the article, it stated that in a solitary universe, the tiny energy of the one and only vacuum looks like a profound puzzle, but in a multiverse, it's just dumb luck. If different bubbles of space have different energies and expand at different rates, galaxies and planets will form only in the most lethargic bubbles. Our calm vacuum, then, is no more mysterious than the Goldilocks orbit of our planet. We find ourselves here because most everywhere else is inhospitable to life. Dr. Lawrence Krauss advocated a similar idea in his book, A Universe from Nothing, where he advocates that the laws of quantum mechanics tell us that particles will burp out of empty space and eventually fill up a universe, and that the universe is more remarkable than the fairy tales that were talked about by Bronze Age illiterate peasants. Dr. Luskin, what do you think of this current topic? Is our universe the result of dumb luck and not the result of a designing intelligence?
Well, Chris, I have not seen that story yet, but I just Googled it while you were talking about it, and it's a really interesting story. This is certainly an old idea, the idea that the universe can sort of create itself. This idea that maybe the universe is something almost like a quantum particle, where quantum particles can just pop in and out of existence seemingly at random. There's no way to precisely predict when exactly quantum particles are going to appear or disappear. So maybe if our universe is like that, then it could just suddenly pop into existence. And this is sort of this quantum cosmology model. I'm not a physicist. I'm certainly, this is not my trained area of expertise. But what I can say is that there are some very easy to understand problems with this model. First of all, this idea that the universe could arise from a quantum vacuum does not mean the universe is actually rising from nothing, because a quantum vacuum is not nothing, okay? A quantum vacuum is something. It's basically a field that exists within space-time. And yes, within our universe, when you have a quantum vacuum, quantum particles can pop in and out of existence. But it's not really what we might call absolute nothing or true nothing. A quantum vacuum is something. It is part of the space-time fabric of the universe. And if you have it, you can get space-time particles, but you need it in order to get these quantum particles in order to pop into existence. So I think it's sort of begging the question, well, where did the quantum vacuum come from? How did that pop into existence? It is not truly the universe coming from nothing. It's the universe coming from essentially a sort of fabric of this quantum vacuum that is sort of like the fabric of our universe. So I think that just get that off the table. This is not the universe coming from nothing. This is the universe coming from something. And everything I've ever seen, what comes from nothing? Well, nothing comes from nothing, okay? Nothing comes from nothing. You don't get something from nothing. The universe is something, and we're not talking about nothing here. So we're not talking about something coming from nothing. So that's as simple as I think you can put it. In my own non-physics expertise, that's my understanding of it.
Well, Dr. Luskin, thank you so much for addressing Quantum Magazine and Dr. Krauss. It sounds like you're saying that the universe is actually the result of intelligent design. This is contrary to the philosophy of materialism, which the Encyclopedia Britannica defines as the view that all facts, including facts about the human mind and will and the course of human history, are causally dependent upon physical processes or even reducible to them. Dr. Luskin, what would you say are the fundamental beliefs or the tenets of the materialistic worldview? Do you see evidence for those tenets? And if not, why not?
Sure. So actually, I wrote a book titled Discovering Intelligent Design. I don't know if you are familiar with this textbook, where we actually go out over the 7 tenets of materialism. And so these are the 7 tenets of materialism that we listed in that book. So first of all, the universe has to be infinitely old or to be appeared by chance without any cause. And that's sort of what the article that you're just mentioning is trying to say. The universe appeared without a cause. Well, I'm sorry, but they haven't actually explained that. If you think about the Kalam cosmological argument, the idea that everything that begins to exist has a cause, the universe began to exist, therefore the universe has a cause. Well, it's not true that you can get something from nothing. And so it's not true that, they've refuted this first tenet that everything that begins to exist has a cause. So anyway, so that's the first tenet of materialism. The second tenet of materialism says that the physical laws and constants of the universe were produced by purposeless chance processes. Then we have the third tenet. We're getting into the origin of life, the idea that life originated from inorganic material through blind, chance-based processes. The fourth tenet goes to sort of the information that we see in life, that the information in life arose by unguided, blind processes. The fifth tenet is we have to also account for the complexity of life, so complex cellular processes and new genetic features developed over time through purposeless, blind processes. The sixth tenet is that all species evolved by unguided natural selection, acting upon random mutations. And then the seventh tenet is that all living organisms are related through universal common ancestry. If I were to, I think, write this book again today, I might change the seventh tenet actually to apply to the origin of consciousness, that human consciousness exists through purely material processes. So these are their beliefs. It's almost like, the tenets of a religion or something like that. They will stick to these beliefs no matter what the evidence says. But when you look at the evidence for each of these tenets of materialism, I think it's safe to say that they're all strongly challenged by the evidence. Of course, what you just mentioned is looking at tenet number one, the origin of the universe. I mean, because the universe began to exist, we can see that from the evidence in our universe. That implies that there is a first cause to the universe. It does not, you can't get away from that first cause like that article is trying to do.
Thank you so much for going over those ideas, Dr. Luskin, because in this next question, we're going to take a look at your article called, Can Materialistic Models Accommodate the Scientific Data? In this article, you spoke about the materialistic model called punctuated equilibrium. Can you tell us more about punctuated equilibrium? Is this model scientifically accurate?
So, punctuated equilibrium is a model that purports to explain why we so rarely find fossils in the fossil record that could be plausibly construed as transitional forms. So, what are transitional forms? According to the classical Darwinian or neo-Darwinian model of evolution, species evolve very slowly and gradually from one form into another. And during that sort of gradual evolution, you've had these forms that are intermediate between, say, one species and another, or one type of organism and another. And if you look at the fossil record, you should be able to find fossils showing these gradual evolutionary transitions. This was sort of in Darwin's day, it was known that the fossil record did not have these sort of transitional forms documenting the evolution of one type of organism into another. And Darwin appealed to the incompleteness of the fossil record to explain, or you might say explain away, the lack of these transitional forms. But Darwin hoped that as more and more fossils were discovered, as we learn more and more about the fossil record, that over time we would find these transitional forms. So maybe we could say 100 to 120, 125 years went by after Darwin first published Origin of Species in 1859. And eventually you get into the 1970s, 1980s, a little over 100 years after Darwin's book was first published. And paleontologists begin to say, you know what? We have to come to terms with the fact that we've been collecting fossils now for over 100 years after Darwin. And we still do not have very many potentially plausible examples of these transitional forms. And this is a real problem for Darwinian, or the sort of modern version of Darwin's theory, which is called neo-Darwinian evolution. We need to think about how we can explain why they wanted to retain evolution, but yet try to explain why they did not find these transitional forms. So punctuated equilibrium was sort of conceived as a model of evolution where evolution occurs essentially rapidly, where basically you have long periods of time where there is very little change going on in species. This is called stasis. And then you have very rapid evolutionary change where species evolve and change very rapidly into new species or new types of organisms. And this is called punctuated equilibrium, where you sort of punctuating this period of stasis with very rapid change. And according to the idea of punk-eq, as it's often called, this change happens so rapidly that there is not enough time for the transitional forms to be fossilized. And so this is supposed to explain why we don't find the transitional forms that are predicted by Darwin's theory in the fossil record. So I would say that punctuated equilibrium leaves a lot to be desired as a model or as a scientific theory or a hypothesis, whatever you want to call it. Number one, it sort of takes the glory of Darwin's theory was that you would have very long periods of time and large populations to get enough trials essentially for these useful beneficial traits to arise and then to be preserved by natural selection. Well, punk-eq robs Darwin theory of both of these sort of probabilistic resources. It says rather than having the evolutionary change happening in large populations over long periods of time, it says that the vast majority of evolutionary change has happened in very small populations during very short periods of time. And that essentially allows too few opportunities for new beneficial traits to arise. And so I think that a lot of biologists have said, look, punk-eq just does not work as a model of evolution. It's requiring too much change too quickly. And biology essentially cannot accommodate this rapidity of change that is required by punk-eq. Another problem with punctuated equilibrium is I'd say it's just unconvincing, and that it predicts that with respect to the fossil record, we're not going to find any confirming evidence, okay? So I like to give this example. Let's say that I were to tell you that I have a videotape that has leprechauns and fairies on it. Okay. But you watch the video and you say, well, where are they? I don't see any leprechauns or fairies. I say, oh, well, you have to understand that the leprechauns and fairies, they actually are on camera. They're just too small or too fast to be seen. Okay. Well, what are you going to say? You're going to say, I don't know. I'm kind of skeptical of that. And so when we hear Punk Eek saying, look, evolution happened, but it happened too quickly and in too small populations for the fossil evidence of evolution to be preserved, that makes us a little bit skeptical. Are we really seeing sort of a compelling scientific theory here? So even Stephen Jay Gould and Niles Eldredge, they even conceded, I think, later in their careers that, look, there's no way to get evolution other than standard mutation and selection. And that raised the question whether, if you're just going by standard mutation selection, can Punk Eek accommodate that? I think it's safe to say that Punk Eek has kind of fallen out of favor among scientists. Occasionally, you will see it invoked to try to explain away gaps in the fossil record or jumps or large abrupt transitions in the fossil record. But they never really have elucidated, I would say, the nuts and bolts of how it actually works. It's just sort of a model. Yes, it's there as an option if you're an evolutionary biologist, but a lot of the details are lacking.
It sounds like punctuated equilibrium has some difficulties, which begs the question, does a materialistic worldview tend towards the progress of science? Dr. Luskin, in that same article on materialistic models, you wrote, materialists hope that if there are a near infinite number of universes, aside from the fact that the multiverse is not observable, the mechanisms proposed to generate a multiverse themselves require fine-tuning, thus exacerbating rather than addressing the challenge of fine-tuning. Even worse, appealing to a multiverse destroys our ability to do science. Dr. Luskin, are there any consequences for the progress of science that come from adopting a materialistic worldview?
That's a great question, Chris. So I think that when we talk about the multiverse, we're talking about the observation that many of the physical laws and constants have to be very precisely accurate, very fine-tuned, as it's often said among physicists, in order for life to exist. We're talking about parameters that have to be fine-tuned to within, say, 1 part in 10 to the 50th or 10 to the 60th power. I'm sure you've had guests on your show that have talked about this, but I'll just give a couple examples of these. If you talk about the gravitational constant, the strength of the force of gravity, if life is to exist in our universe, it has to be fine-tuned to within 1 part in 10 to the 35th power. The cosmological constant, which is related to the expansion rate of the universe, has to be fine-tuned to within 1 part in 10 to the 90th power. The cosmic mass density at Planck time, very early in the universe, is said to be fine-tuned within 1 part in 10 to the 60th power. We go on and on and on about various fine-tuning parameters. The initial entropy of the universe is supposed to be fine-tuned to within 1 part in 10 raised to the power of 10 to the 123rd power. Okay, so this is just astronomical fine-tuning if we're going to be able to get life to exist. And so what many materialists have said as well, this makes a life-friendly universe seem to be fairly improbable. So how do we get around that as we propose this idea called the multiverse, the idea that our universe is just one of a near infinite multitude of universes, and ours just happen to get lucky enough to have the right values and parameters for life to exist. So there are a number of problems with this idea, although it is sort of in vogue these days as an alternative to intelligent design. I think that intelligent design on its face is sort of the most simple and persuasive explanation for this very precise fine-tuning of the laws and constants of nature so that life can exist. But the multiverse, it's proposed as an alternative to intelligent design, and there's a number of problems with it. So first off, what is the mechanism that keeps cranking out all these hypothetical universes? And how did that mechanism originate? We don't really see an explanation for that. There's also this idea that the theory relies on the assumption that these universes would all be different from one another. So if there are so many universes, why wouldn't many of them have all or the same characteristics? Another problem is that we can only observe one universe, okay? So there are some models of multiverse generation that make certain testable predictions, but at the end of the day, all that we can really observe is one universe. And so that means that we're not able to observe this vast ensemble of other multiverses. So I think that that makes the multiverse hypothesis more in the realm of sort of philosophy or speculation rather than well-confirmed science. But yeah, as you said, I think that multiverse thinking, and this is sort of endemic to materialism, is it destroys our ability to do science, okay? So here's how I would put this, right? Let's imagine that a team of researchers discovers that everybody in a town of 10,000 people gets cancer within a year. We'll call that a cancer cluster, okay? And now let's say that it's determined that the likelihood of everybody in that town getting cancer within a single year is 1 in 10 to the 10,000th power, okay? So normally scientists would just reason that such low odds establish that chance cannot be the explanation of this cancer cluster. And there must be some physical agent that is causing cancer in the town, okay? So if you are, say, a defense attorney defending this town, let's say there's a chemical factory in the town. You're defending the chemical factory from this accusation that they caused this cancer cluster. And what would you say? Well, you would say, well, Your Honor, imagine that there are 10 to the 10,000 universes. And our universe just happens to be the one where this very unlikely cancer cluster arose, purely by chance, okay? So you can let my client off the hook because there are all these other universes where there is no cancer cluster, and we just happen to live in the very unlucky universe where a cancer cluster arose right next to my client's chemical factory, Your Honor. So my client is not guilty of causing this cancer cluster. We should let them off the hook. And the multiverse is what is really to blame for this cancer cluster in this town. So, of course, you're never going to win that case. The judge is going to say, get out of town. The best explanation for this very unlikely cancer cluster right next to your chemical factory is not chance, not a multiverse, but that your chemical factory is the cause of this cancer cluster. And so, well, maybe the multiverse advocate is going to say, well, you can't say there aren't 10 to the 10,000 universes out there, right? But that's the point. There's no way to test this. There's no way to take it seriously within a scientific context. Multiverse thinking makes it impossible to rule out chance, which essentially eliminates our basis for drawing scientific conclusions. When we say that something is so unlikely, there's no way it could have happened, under natural circumstances, we're supposed to then go to, other causes. There's no way that it could happen. So we're supposed to look for some law-based circumstance rather than just saying it happened by chance. But multiverse allows you to sort of take chance to an absurd degree, and it destroys our ability to rule out chance and make scientific conclusions. So that's a problem for science. I think that the multiverse sort of leads you down a path towards sort of the destruction of our ability to do scientific reasoning.
So essentially, if you adopt this multiverse idea, it truly has completely hindered your ability to do science. I wanted to ask you this other question. Now that you mentioned this sort of attorney-like setting, I'm very interested in this kind of subject. I studied forensic science, and I wanted to know, how would you describe the relationship between intelligent design and forensic science?
Forensic science is a good example of a field that uses intelligent design reasoning. Because what does forensic science do? You find a dead body, you want to understand, how did that person die? Did they die due to natural causes, or did they die due to intelligent causes, which is otherwise known as murder? And so forensic science is in the business of trying to either make or rule out design inferences. You can say, oh, well, this person, we've done the autopsy, it looks like they just died of a natural heart attack. We're gonna rule out making a design inference. But if you then find, that there's poison in the body, and there's a stab wound in their back, and you see a bunch of poison near the stab wound, and it seems like, okay, well, someone actually injected poison into the body, and this poison is known to cause heart attacks. Well, now you're starting to make a design inference. And then you look at other evidence and you say, oh, well, turns out that this person's husband bought a needle set and the same poison 2 weeks before the wife was murdered. Okay, so now you're starting to put together, you can actually identify who is the intelligent agent responsible for this murder. Of course, these are sort of gruesome things, But at the end of the day, we're able to make a conclusion because we can trust what the evidence is saying to us, and we can find evidence that is best explained by an intelligent cause. But if we use multiverse thinking, then the murderer, the husband, might be able to say, oh, well, we live in this multiverse, and in every other universe, it's exactly the same as ours, except, there is no random glitch on my computer where it accidentally ordered the poison and the needles, and there's no random stab wound that didn't actually happen. It's just, sort of happened because in the multiverse, anything can happen, random things can happen. And so it's just chance that all this evidence points towards me being the murderer, but I'm really not. So that's what the husband could argue, that, there's just gazillions of universes out there where he's not the murderer, exactly like our universe, except, the truth that he's not the murderer is clear in that universe, except in this one, it looks like he did murder his wife, even though he didn't. So the multiverse really eliminates our ability to do reasoning, because you can never rule out chance. You can never actually make a conclusion based upon the evidence, because you can just say, oh, well, this is just because we happen to be in that one universe where crazy things happened, and it looks like this is pointing to some conclusion, but it's just because we're in that one very rare, unlucky, strange universe where something weird and oddball happened. And so, yeah, the multiverse does, I think, destroy. If we start to apply multiverse thinking to our everyday lives, you can never make any conclusion at all. It's just always, randomness is dominating everything that we see.
I'm very grateful you covered those points, Dr. Luskin. There's certainly food for thought. Speaking of which, you have an article on the fruitfulness of intelligent design called Science Stopper: Intelligent Design as a Fruitful Scientific Paradigm. In this article, you covered 12 different fields of science that have progressed because of the theory of intelligent design. Can you tell us more about those scientific publications and whether or not intelligent design helped generate research on new discoveries?
So, a good part of what I do at my job here at Discovery Institute, Chris, is I manage our research program. It's called the ID 3.0 research program, or at least I help to manage the research program. And ID has helped to make a variety of advances in various scientific fields. And we funded a lot of that research and helped, the people who were doing the research to have the resources they needed to do their research. And then, they published that research in peer-reviewed journals. This is very normal for a research program. We certainly do this. And we're very grateful to be a part of these, supporting these projects. So what are some of these fields and some of these projects that we've supported? Well, so intelligent design encourages scientists to study what we call complex and specified information. It's basically a type of information which in our experience only comes from intelligence. And so ID predicts that we will find high levels of complex and specified information. We often call it CSI for short. It predicts that we will find high CSI in biology. And so we have funded research here at Discovery Institute that has tested whether proteins contain high levels of complex and specified information. And so how do we do that? Well, we can test for whether the amino acid sequence of a protein has to be, again, finely tuned in order for that protein to be able to function. And so you can do what are called protein mutagenesis experiments, where you mutate the sequence of a function or the sequence of a protein, and you ask, can it still perform its function? And then you can measure how precise that protein's amino acid sequence needs to be in order for that protein to function. And so we have published peer-reviewed, or not we have published, but researchers that we have funded who is doing this intelligent design research, finding high CSI in proteins, have published their research in journals such as Journal of Molecular Biology, Protein Science, and Biocomplexity. And so it's very interesting because we find that there are very precise amino acid sequences that are needed for proteins to be able to do their function. Another field where ID, again, makes good predictions is physics and cosmology, where ID has inspired scientists to seek new instances of fine-tuning of the laws and concepts of physics for life. And this has led to new fine-tuning parameters, such as the galactic habitable zone, the idea that there are only certain regions within the galaxy where life can exist. In fact, one of our fellows, Guillermo Gonzalez, published the cover story in Scientific American a number of years ago talking about his idea of the galactic habitable zone. So again, we're seeing these ideas that are coming for Guillermo Gonzalez, at least, coming out of his intelligent design paradigm, making it into the mainstream scientific literature. Another field where ID makes prediction is in the field of evolutionary computation, where ID sort of has inspired and led people to do theoretical research into the information generative abilities of Darwinian searches versus intelligent searches. You can actually model these different types of searches on a computer program and perform what are called evolutionary algorithms, where we can try to solve certain problems using a trial and error process that is supposed to mimic Darwinian evolution. And what has been found is that these evolutionary algorithms, yes, they can do certain interesting things, but there are limits to what they can produce. And most importantly, they can only produce information that has been pre-programmed into those programs by the programmer. They can't actually produce anything new that was not already given to them. And so some of the research that we have funded or supported in this area, in this field of evolutionary informatics, has been published in IEEE journals, such as IEEE Transactions on Systems, Man, and Cybernetics, in the journal IEEE International Conference on Systems, Man, and Cybernetics, in the journal PLOS One, and in other journals as well. So these are just examples of ID is doing both experimental research and also doing theoretical research to find evidence for design in nature. We could go on and on about this, but I think it's safe to say that ID makes predictions in a variety of different fields, Chris, that can be tested, and we're producing peer-reviewed research that supports the evidence for intelligent design in nature.
Dr. Luskin, before we close, I wanted to look with you at an objection that might be raised to your last answer. A skeptic of intelligent design might say that the theory isn't actually making any real predictions, but rather is making retrodictions. Dr. Luskin, is this true? Is intelligent design a retrodictive theory?
Intelligent design does make predictions, where it's made predictions before we actually made certain discoveries. But I think that in some cases it has also made retrodictions, and that's okay. I think that many theories are used in a retrodictive manner. Let's get into this and sort of break it down and talk about what do we mean by all this. Well, a prediction is when you can obviously say that based upon my theory, I think we're going to find X. And when a theory makes successful predictions, that tends to bode very well for its usefulness and its truthfulness and its merits as a scientific theory. So what are some examples of predictions that intelligent design theory or ID theorists have made based upon intelligent design, and they came to be seen as correct? Well, one of them, I think, this is one of the most well-known examples, is the idea of junk DNA. So I've been in this debate. Today, it's in 2022. I've been in this debate since the late 90s. And I can remember when I first got involved with this debate that we would get beat over the head with people saying, you know what? We know that the vast majority of our DNA is useless genetic junk or junk DNA. And that shows that no designer would make the genome, because no designer would fill our genomes with useless genetic junk. It must just be the result of random mutations accumulating evolutionary garbage over long periods of time, millions of years, blah, 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 and filling up our genomes with junk. And no designer would do that, but random mutations would do that. And so ID theorists immediately said, this is back in the mid to late 90s. Well, they said, well, look, there's still a lot we don't know about the genome. In fact, at that time, Chris, you may or may not remember this. I don't know exactly how old you are, but the Human Genome Project was not even finished until 2001. Okay, so we did not even know the full genome of the human body until 2001. And yet people were talking about junk DNA throughout the 1990s, even back into the 1980s, claiming that our genomes were largely genetic junk. And so before the Human Genome Project, we were very easy to say, well, look, there's a lot we don't know about the genome. So let's not assume that this DNA that we don't understand is just genetic junk that was put there by blind evolutionary processes. Let's not make any assumptions. Let's wait and see what the evidence says. And meanwhile, based upon my intelligent design paradigm, I'm going to anticipate or predict that the vast majority of that DNA is going to turn out to have some kind of a function. Maybe not every single nucleotide, but most of it is going to have some kind of a important function. So lo and behold, what then happened? Well, get into the 2000s, and the number of DNA elements that were found to have function among the non-coding or junk DNA parts of the genome began to skyrocket. Okay, in fact, the junk DNA, or sorry, the number of genes that we knew of in the human body leveled out at around 19 or 20,000, and that was like in the year 2001 or 2002, somewhere around there. And we have discovered just a handful of genes since that time. So you can look at the curve of the number of genes that we have in our bodies. And it's, it basically flattens out when you compare the number of genes we know of compared to time. It flattens out around 2000, 2001. We basically had discovered all the genes that were in the human body. But yet, what about the non-coding DNA? The DNA that is not in the genes, that does not code for proteins, but still seems to be there for a reason. Well, the number of genetic elements that have been discovered that among the non-coding or quote unquote junk DNA parts of the genome, the functions known for those parts of the genome have just skyrocketed. I mean, I can show you a diagram if you want to see it, but it's really quite incredible. The amount of DNA that we now know has an important function. And a lot of this goes to the credit of the ENCODE project. ENCODE was a huge consortium of scientists from all around the world who got together to try to understand what the non-coding DNA in our genomes is doing. And they published a set of papers around the year 2012, which came out and showed that they found that over 80% of our genome is involved in at least one biochemical activity, meaning that it's somehow biochemically functional. So that right there suggests that there is an important function for the quote unquote junk DNA, that it's not even necessarily junk if over 80% of our genome is known to have a function. Well, what about the other 20% of the genome? You might say, well, Casey, doesn't that mean that 20% of our genome is just genetic junk? Well, in the ENCODE project, they only, initially at least, they only studied about 187 cell types out of the thousands of cell types that are found in the human body. And it turned out that some stretches of our DNA are only active. They're only transcribed from DNA into mRNA. They're only transcribed in certain cell types and in certain stages of the human life cycle. So that means that it's very difficult to catch every cell type in the act. And we haven't only studied about 187 cell types up until at least when ENCODE was published in the human body. And they actually had a quote from one of the lead ENCODE researchers who was speculating that if we were to do studies on every single cell type, throughout the entire life cycle, we would find that 100% of our genome is actually functional. Okay, so 100% of our genome, or even 80% of our genome being functional, is a far cry from the, say, 2% that was claimed to be functional. Maybe, if you're lucky, you get up to 10 or 20%, but, much, much less than 80% of our genome being functional. Well, so we could say the 2 to 10% of our genome that was predicted by the junk DNA evolutionary paradigm to be functional is now known to not be correct. The empirical data has proven the intelligent design junk DNA of the paradigm of the genome to be correct. And we now know that the vast majority of our genome does have some kind of an important function and is not just useless junk DNA. So this is very interesting. This really sort of, I think, shows that ID is making good predictions. It made this prediction long before we made these discoveries, and yet ID was making these predictions in the face of what critics were saying would refute intelligent design. And we were saying, no, let's take a more cautious wait and see approach to the evidence. Let's not just assume that what we don't know is therefore non-functional. So I think that's a good example of a prediction that ID has made, a very useful one, in fact.
Well, Dr. Luskin, we've now come to our final question. From our personal encounter, I know that you're a Christian. And how would you say that the design of this world brings glory and honor to Christ Jesus?
I am a Christian. I would say that, my belief that the God of the Bible is the designer doesn't necessarily derive directly from the raw data of nature. I'm a Christian for many reasons. I believe there are many good philosophical, historical, theological, and occasionally some scientific arguments that the God of the Bible is the best candidate for being the designer. And so that's why I'm a Christian. And also, I think that there are good apologetics arguments that Christ rose from the dead and he really did die for our sins. So I think there's a lot of good arguments. Some of this goes outside of intelligent design. So let's just sort of get that on the table. We're going beyond the field of intelligent design right now. But I think that intelligent design is a scientific theory which says that many features of life in the universe are best explained by an intelligence. Well, that is very consistent with what the Bible teaches when it says, for example, in the book of Romans, Romans 1:20 says that God is clearly seen in what has been made. Or Psalm 19, which says the heavens declare the glory of God. So I think when we see this evidence and we say, you know what, there's all this evidence for a designer, for a creator being behind it all, I think that right there does bring glory to God, because I think that God has set up the universe to display His glory. And so when we recognize that, and we can see that in intelligent design, that there is evidence for a designer, evidence for a creator, and I think that is very consistent with what I believe to be true as a Christian. But I'm coming to that conclusion within intelligent design theory. I'm coming to that conclusion through a scientific investigation. I'm not concluding this because, of some divine revelation, because, the Bible tells me so to speak. I do believe the Bible, but I believe this intelligent design because of what the scientific evidence is showing. So it's very interesting to find this convergence of both what science is saying and also what my faith is saying. And I think that we can see that the two are very coherent and complementary to one another.
Dr. Luskin, thank you very much for your time. It was an absolute joy. And to our listeners, thank you very much for taking the time to learn with us on current topics in science, where scientific discoveries are examined in light of the origins issue. You can find Dr. Luskin's biographical information, his lectures, his scientific papers, and more information in the description. Additionally, you'll also find the Discovery Institute website and a link to the Christ Jesus Ministries merch store. Please share and subscribe to the Current Topics in Science podcast. It's available on iTunes, Stitcher, Google Podcasts, Spotify, and iHeartRadio. Thanks again for listening, and remember, the truth saves.